Section 5.5, Radical Equations. This begins on page 182. Question 1, square the expression. So they're asking us to square it. So like that, which means we have square root of 3x minus 5 times the square root of 3x minus 5. So that gives me 3x minus 5 squared, because there's two of them. It's like saying I have the square root of x times the square root of x. That is the square root of x squared, right? So now when I take the square root of a square, it becomes itself. So this will give me 3x minus 5. 2. Determine the restriction on the radical equation. Well, first question is, what is a restriction? I'm supposed to find that. Basically, you have to make sure that the number under the square root is going to be positive. So say I have the square root of 16. Well, that works. That equals 4. But the square root of negative 16 does not work. That is not a real number for an answer. That's an imaginary answer. What you do is you take whatever it is under the square root, and that has to be greater than or equal to 0. So let's do 2c. The number, whatever is underneath the root, has to be greater than or equal to 0. So I'm just going to take the stuff underneath the root. I'm going to ignore the rest of the question right now. So I have 2x plus 3. That has to be greater than or equal to 0. Subtract 3 from both sides. Divide both sides by 2. The restriction is x has to be greater than or equal to negative 3/2 for this to work. So if I am doing some sort of calculation and I get an answer that x equals negative 2, then I throw that out. That would be considered an extraneous root or an extraneous answer, which would not work once I checked it with my restrictions. 3h. Square root of 10 minus 3x equals the square root of 2x plus 20. I have two square roots here, so I need to do it twice. Let's do my 10 minus 3x first. So 10 minus 3x is greater than or equal to 0. Subtract 10 from both sides. Divide both sides by a negative 3. Remember to switch the sign. There's one restriction. My other square root will be another restriction. 2x plus 20 has to be greater than or equal to 0. Subtract 20 from both sides. Divide both sides by 2. Let's put those two restrictions together. So I have here x is less than or equal to 10/3. X is greater than or equal to negative 10. Our small number is negative 10. Big number is 10/3. X is going to be in the middle. X has to be greater than or equal to negative 10. So remember, it eats the bigger number. And x is smaller than or equal to 10/3. 3D, solve the radical equation. It doesn't ask me to do the restriction, but it might. If I was asked to do the restriction, then I would go x minus 1 is greater than 0. So x has to be greater than or equal to 1. But it didn't ask for that one, so you're not required to do it. It did say solve. So let's solve this. We need to find out what x is. Best way to do this is to try to isolate the square root first. So I'm going to divide 2 on both sides. So I'm going to get x minus 1 equals x over 2. The reason why is if I'm squaring this and I have other numbers around that square root sign, it sometimes makes it very messy. I would have to do some FOILing and I might not get rid of all of the square roots then. So I'm going to try to isolate the square root like I did in this case, and then I can square it. I square both sides. I'll have x minus 1 equals x squared over 4. I don't have any more square roots. Let's multiply both sides by 4. Okay, let's subtract both sides by 4x and add 4 to both sides. Now I've been asked to solve it, so that means I have to find the roots or the zeros. So I have to factor this one now. Two numbers that multiply to 4 and add to negative 4. So x minus 2 equals 0. Now that's going to be the same. X equals 2 is my answer. 3h. We need to solve this as well. I'm looking here. I have the square root of 3x plus 10 plus 5 equals 2x. Let's move that 5 to the other side. I'm trying to isolate my square root. Let's subtract 5 from both sides. And now I can square both sides. Now remember, 2x minus 5 squared is really this. So when I multiply this out, that's going to be 4x squared minus 10x plus 25. So 4x squared minus 20x plus 25. Let's subtract 3x from both sides and subtract 10 from both sides. Okay, so we need to factor this. So 4 and 15, we're going to add to negative 23. Let's try these factors. That would be 3 and 20. That's really close. If we make negative 1, negative 4 perhaps, that would work. So minus 3x. Okay, let's factor this. Careful with your signs. So x minus 5 can equal 0, so x equals 5. Or x minus 3. Let's just quickly do the restrictions. 6. Heron's formula for finding the area of a triangle with sides A, B, C is A equals the square root of S times S minus A, S minus B, S minus C, where S equals A plus B plus C divided by 2. Find the area of a triangle with sides 6, 8, and 12 centimeters. Okay, so they're saying that the sides of the triangle are ABC. So let's say 6 is A, 8 is B, 12 is C. And to find this, we have ABC already. That's nice. We need to figure out S, so let's use this formula here to find S. A is 6, B is 8, C is 12, and divide that all by 2. Okay, so let's plug this in. So A equals the square root of 13 times 13 minus 6 times 13 minus 8 times 13 minus 12. Stuff inside the brackets is done first. Okay, let's multiply all that together. So the area is square root of 455 centimeters squared, because area is squared.